Very good evening, my dear GW soldiers. Very good evening, very good evening, very good evening. First of all, kindly let me know, am I audible? Kindly let me know, my dear students. Am I audible? Audio video is clear? Please, everyone. Kindly let me know fast. Audio video is clear? Yes, Sham. Very good evening. Yes, sir. All clear. Very good, bacha. Very good. So, my dear student, today we are going to discuss properties of decomposition. Yes, Sham, Jadi. Very good evening, my dear GW soldiers. Very good evening, very good evening, very good evening. Now, today we are going to discuss properties of decomposition. In this lecture, we discuss what is the meaning of lossless join and what is the meaning of lossy join. But before discussing these things, what we done till now, just a quick recap about each and everything, whatever topic we discuss. First of all, in the very first class, we discuss RDBMS concept. What is the meaning of relational? What is the meaning of arity? Yes. Screen of Mohar. Yes, you can learn the DBMS directly from this lecture also. But please watch the previous lecture also. That will helpful for you. Okay, because when we discussing the normal forms, then previous lecture really helpful for you. But today, whatever concept are using or previous lecture, I will tell you. Don't worry about that. Okay, bacha. Now, listen. What we done till now, I am giving the recap here. We discussed the RDBMS concept. What is the arity, degree, cardinality? What is the meaning of relational schema, relational instance? Each and everything we discuss in RDBMS concept. After that, we discuss FD concept and type of FD. After that, we discuss attribute closure. Then we discuss the keys concept. In keys concept, my dear, we discuss super key, then candidate key, and finding multiple candidate. Finding multiple candidate key. Finding multiple candidate key. After that, we discuss the membership set and equality between two FD set. Equality between two FD set. After that, we discuss minimal cover. And before the minimal cover, we discuss finding the number of super keys and FD closure of FD set. Closure of FD set. Okay, bachcho? Till now, each and everything is crystal clear. Again, if you want, yes. Very good evening, Priya Chaudhary. Again, please listen. Only 5 minutes give me. I will revise each and every topic thoroughly, completely. Okay, then we'll start. Because I know there is a Saturday Sunday gap. I will revise each and everything what we discuss. Here just I have written the name of topic, but here I will quick revision of each and everything. Okay. So can I start, everyone? Write down yes or no. Write down, everyone. Do it fast. Tell me fast. Please. Everyone. Now listen. What we discuss. Screen of Mohar. I am starting from the starting. Okay. I am start from the starting. Don't worry. Listen carefully. Okay. Now, in the very first class, we discuss RDBMS. What is the meaning of RDBMS? Relational Database Management System is a system in which database is represented in the form of relation. And what is the meaning of relation? What is the meaning of relation? Relation is nothing, it's a table. A table is a collection of row and column, in which row is called tuple or record, column is called field or attribute. Then we discuss some terms. First, arity, degree. What is the meaning of arity? Arity means number of attribute, my dear. Arity means number of attributes, fields, column. Second one is cardinality. What is the meaning of cardinality? Number of tuples and number of rows, my dear. After that, we discuss relational schema. Relational schema is nothing. Table abstraction means table heading, a name of the table. For example, whatever university you are reading, let's suppose you are reading studying Mumbai University, and Maharashtra, Mumbai University, and there are 1 lakh student in Mumbai University, but I don't want the details. I just want what is the name of table and whatever the attribute that table contain. So student table name and what are the attribute, that is called schema. Okay, hiding the unimportant detail, show only essential feature. Then instance. Instance means what? Set of records, my dear. Then we come to the FD. What is the meaning of FD? X functionally determine Y. Sir, what is the meaning of function? A plus B ka square, A cube plus B cube, yeah, A plus B ka cube. Sir, which function? Sir, which function? So function means yes, yes, yes. Screen off more. You can go. Don't worry. DCMCA, yes. Okay, don't worry. Now listen. FD, functional dependency. What is the meaning? Here, first of all, it is mentioned function. What is the meaning of function? Function means X functionally determine Y. What is the meaning of X functionally determine Y? Whenever X value repeat, corresponding Y value must be same. Are you getting my point? Corresponding Y value must be same. And how we interpret? For a X value, there must be unique value of Y. And how we say and how we remember? Whenever my roll number repeat, my result will be displayed. My result will be displayed. And in a technical term, how we interpret? If there are two tuples such that if t1.x equal to t2.x, then t1.y equal to t. After that, we discuss the type of FD. Trivial FD. Trivial FD is nothing. X tends to Y is trivial if X is a superset of Y. Example, xy to X, yeah, xy to Y. This is the meaning of trivial FD. Yeah, A, B to. Okay. And non-trivial means X intersection Y phi. Nothing is common and they satisfy the FD depth. Okay. And next one is semi non-trivial, but which we don't use. Neither X in superset of Y, neither common is not intersection phi. Neither trivial, non-trivial pure. That is called semi non-trivial. Then we discuss attribute closure. What is the meaning of attribute closure? Your chat must be continue beta. What is the meaning of attribute closure? Set of all possible attribute which is determined by any attribute set X. What I'm saying, any attribute set. Set means what? It may be single attribute or more than one attribute. Then if all attribute of relation R are getting with the help of attribute X, then X becomes super. Or X may be simple or maybe more than one attribute. Then we find the concept of super key. If we are getting all attribute, if I am able to open the lock of this building, then that becomes super. And if it is minimal, then it becomes. What is the meaning of candidate key? Candidate key is nothing minimal of super key. If I am saying AB is the candidate key, that means neither from A nor from B not getting all attribute. Minimum से minimum, minimum से minimum, minimum से minimum, minimum से minimum. AB is required. AB is required. Then how to find candidate key? Whatever attribute not present in FD, right hand side, whatever attribute not present in right hand side, that must be in part of candidate key. But I told one trick how to find multiple candidate key. First find any one candidate key and whatever attribute that present in that candidate key, that is prime attribute. And if there is a such type of FD in which any X attribute determine the prime attribute, then multiple candidate. Then we discuss membership set, logically implied or not. Then we discuss FD between two, equality between two FD set. One FFD set is given, one GFD set is given. When they are equal, if F cover G true and G cover F true. What is the meaning of F cover G? Ki F cover all the FDs of G. Yeah, in a technical language, you can say all the FDs of G are logically implied in FFD set. And G cover F means G cover all the FDs of F. Yeah, in a technical language, you can say all FFD are logically implied by GFD set. After that, we discuss minimal cover. Before that, we discussed the number of super keys by Venn diagram by two other approach. Then we discuss the closure of FD set. What is the meaning of closure of FD set? Whatever FDs we can determine from the given FD set, whatever additional FDs we can determine, these all are called closure of FD set. And we discuss the closure of FD set without any given FDs. Without FDs means if relation RAB is given, yeah, RABC is given, then what is the FD of closure? FD closure F plus. Or if FD set is given, then what is the closure? We discuss without FD and with FD also, and trivial, non-trivial each and every. After that, we discuss the minimal cover. In the minimal cover, we discuss first of all elimination of redundant FD. After that, we discuss step second, extra attribute elimination on LHS. Then, first of all, what is the step first in minimal cover? But before the discussing the minimal cover, we discuss the redundant FD concept. Redundant FD means what? Is a FD. If we delete that FD, after deletion does not affect the power of FD set. Means whatever earlier you are able to do, right now after deletion you are also able to do. That is the meaning of extra FD. Extra means what? That is extra. Means if you remove, not affect in your health. Getting my point? So this is the meaning of. Then we discuss the minimal cover. It is a 3-step I told. First of all, split the attribute RHS contain only single. Second, we find the redundant attribute on LHS. Then third step, we find the redundant FD. So these are the topic which we discuss. Now kindly let me know till now each and everything is crystal clear. बना दीजिए दिल everyone. It's just a quick recap of each and every topic. I not only written the name of the topic, although I explain also in a short form. Okay. Now we discuss the minimal cover. Everyone. Yes, Sham. I am discussing the homework question also. Don't worry. So I discuss concept of minimal cover. There are 3 steps. Step number 1 is what? Split the FD such that RHS contain single attribute. RHS contain single attribute. Step second, what we done? Find the redundant attribute. On LHS and delete them. And delete from Jaideep and screen of Mohar and Sham. I am for that purpose I am writing step. Then I will discuss after that immediately. Step number 3. What is the step number 3, my dear? Find the redundant FD and delete. Clear? Now we are discussing this gate question. May I start, everyone? Jaideep, may I start? So बच्चों, the question we W determine X, Y determine B, Y determine X, and Y determine Z. This is the step 1. This is the step 1, beta. Set the FD such that RHS contains single attribute. This is the step 1. Can everyone crystal clear? The step 1. Now step 2. Find the redundant attribute on LHS. Find the redundant attribute on LHS. So how we find the redundant attribute? Here VW determine X. Here either V is extra or W is extra. What we do? We take the closure of W. When you take the closure of W, what we are getting? Are getting only mean to say V is not extra. V is not extra, my dear, not extra. But when we take the closure of V, what happen? Are getting W So here you can say W is extra because you are getting from the V also. What we do, we are getting this. Here everyone, what is the input for step third? What is the input for step third? Are getting 3 determine W, determine X, Y determine V, Y determine X, Y determine. Clear everyone? Each and everyone crystal clear? Kindly let me know please fast. Everyone. Crystal clear? Please. Now we have to find redundant FD. And how to find redundant FD? Just forget that FD and find in other. Find in other. Bacha? Now listen. Forget this FD and take a closure of V. What happened? X, you are not getting W, that is required. Find the closure of V. What we are getting? P, W, only W. Find the closure of Y. Y, X, Z, that's all. Find the closure of Y. What we are getting? Y, Z, we determine W and X also. Are getting X, not required. Is not required, my dear. Now take the closure of Y. Forget the FD number 5 and 4 as well. 5, P, W, X. You are not getting Z. This. So what we can say, my dear student? What we can say? What is the minimal cover? What is the minimal cover, मेरे छोटे भाई और बहनों? Your minimal cover is we determine W, we determine X, Y determine V, Y determine. Clear everyone? Each and everyone clear? Determine W will determine X, Y determine, Y determine. So here A is the correct answer for. A is the correct answer. Crystal clear? If it is crystal clear, kindly write down in chat box. Everyone. Please. Each and everyone, let me know fast. Now, my dear, now we are going to discuss the different topic, property of decomposition, and two question I given as a homework also that you done maybe. Now, if you not done, please let me know. Already I given the answer for that. Okay. Now we are going to discuss, my dear, property of decompose, my dear, of compose of. Okay. So there are mainly you understand, you learn in your BTech, those students read the DBMS normalization. What we do in normalization? Normalization, we are splitting one table into more than one table. Why we are doing that time I will discuss when we read the normal form. Okay. But my question is, sir, what is the two key pillar of this decomposition? There are two pillar, Karan and Arjun. Karan and Arjun, I am saying what properties of decomposition. There are two pillar. First one is what? Lossless join. First one is what? Lossless join decomposition. Second one is dependency preserving. dependency preserving. My dear student, please try to understand. Whenever we read normalization, what we are doing, we are split a one table into sub tables. But what is the main key concept? That time I will discuss. But these are based on two pillars. First one is lossless join, and second one is dependency preserving. What is the use of minimal cover? Very good question. What is the use of minimal cover? Seema, very good. Or I am telling not only the use of minimal cover, what is the use of each and everything I am telling. Okay. Now you will feel happy and feel relaxed also. What is the use of all these things? Okay. RDBMS concept, you know it. What is the use of FD? First of all, if FD not exist now, please try to understand. If no FD not exist, you are not able to find attribute closure. You are not able to find attribute closure, then you are not able to find candidate super key, then not able to find candidate key, and so on. Now, what is the meaning of minimal cover? What is the importance of minimal cover? What is the use of minimal cover? Minimal cover means what? You can say it's a simplification of FDs. It's a simplification of FDs, and you write each and every FD in a simplest form. And if there is any extra FD, any repetitive attribute due to any reason, you are eliminating each. Means it is the last and simplest FD set of that particular relation, which of that particular, let's suppose this is one relational schema, for that these FDs are given. Might be there is a some extra FD, there is a some extra attribute also. So what is the objective of minimal cover? Objective of minimal cover is to do the simplification. Mean to say, if there is any extra FD, if there is any redundant attribute, eliminate. And after elimination also, whatever work done by these FD set, given FD set, and whatever FD we are getting after minimal cover, both having the same work, both having the same work. Are you getting my point? For example, beta, very good, Sima. For example, this is the question na. This is assume F. P determine W. P WX determine, and Y determine V. Y determine Vx. Y determining Vx. And Y determine Z. Sima, each and every one, please find the F cover G and G cover F. F cover G and G cover F. P2 X, Y2 and Y2. Please check F cover G and G cover F. To remove data redundancy, no beta. First of all, FD simplification. Data redundancy we use in normalization. Okay, don't worry. For that purpose, we have a normal form. Seema, Sham, clear? Now you write down, first of all, calculate F cover G and G cover F. Then easily you will get it. Do it fast. F cover G and G cover F. F cover G and G cover F, might. F cover G. Write down these FDs. Take the X. X both. Y close. Y V X. Add. Forgetting. Yes, you. F cover G. F cover G. Now check G cover F. Now check G cover F. What we do? Write down the FFD. Write down the FFD. And W. W determine X, Y2 Vx and Y2, and take the closure in, take the closure Wx. We are getting, but again I am taking Y closure, what is Y, Z, W and V X also. Y2 Vx, yes we are getting, Y2 Z we are. Our F is also true. What we can conclude, what we can conclude, we can conclude F equivalent into say Seema. Are you getting beta? Seema, are you getting what is the meaning? He mean to say whatever given FD, done the simplification, done the simplification with the help of minimal cover. And what is the good thing? What is the good thing? After simplification also, not any harmful, not harmful. Mean to say whatever work, please feel it. I want to tell you in non-technical language. Why? If you understand from bottom of your heart, na, definitely you will never ever forget. So what is the objective of minimal cover? Whatever given FD is here, like here you can see it having some extra attribute also, yeah, some redundant FDs also. Then when what we done after the minimal cover, we done the simplification. We done the simplification of the FD, and not only simplification, whatever work done by earlier by the given FD set after the simplification means remove the extra FD, remove the extra attribute, same work now done by FD set. That is the meaning of minimal cover. As the name indicate, minimal cover. With the help of this is the minimum. That is, this is also called as irreducible set. Irreducible set mean to say it cannot be reduced. It cannot be reduced further. This is the last, yeah, minimal. Clear, bacha? Each and everyone crystal clear? Write down in chat box, everyone, please. So, my dear student, first of all, properties of decomposition. I am going to explain properties of reply in chat box. Thank you, Jadeep. Shyam, very good, Sima. Listen, everyone. Properties of decomposition. There are two properties. First of all, lossless join, and second one is dependency preserving. So, first I am discussing what is the meaning of lossless join. What is the meaning of lossless join, my dear? Let us assume one table, one relation is decomposed into sub-relation. One relation is decomposed into sub-relation. There is a one table which is decomposed into sub-relations, two sub-relations, two sub-relations. Then when we perform the natural join, when we perform the natural join, we are getting original relation R. We are getting, yes, of course. Yes, of course, Seema. In normalization, because when we read the normalization, if you read the normalization, na, so in normal form decomposition, first rule is what? Find, first of all, find the minimal cover. Clear? Correct, beta. In directly, indirectly, it will reduce the cost. Now, because cost, I am right now not saying, because cost is depend on the indexing also. If you feel the DBMS, then if we are talking about the hardware part, then storage part, then indexing come into the, that time we are discussing code, but indirectly you can say, okay beta. So what I am telling, if a relation R is decomposed into sub relation, then if we perform the natural join, then you are getting exact relation R, exact relation R, then it is called lossless join. mean to say mean to say if you are not getting any spurious tuple, if you are not getting any spurious tuple, then you can say lossless join. But if when you perform R1 join R2, you are getting greater, means some spurious, yeah, extra, yeah, spurious tuples, then lossy. Now you have to understand first of all, sir, what is the meaning of this? What is the meaning of this? This is nothing, it's a natural join. This is nothing, it's a natural join, my dear. It's a natural join. So before understanding each and everything, I am discussing natural join. So I will tell you three methods to check lossy. Three methods. You can use any one. You can use any one. Okay. Lossy, lossless. So my dear student, first of all, I'm discussing R natural join S. And when we discuss the relational algebra, that time we will discuss this point in detail. But right now I'm explaining what is the meaning of natural join. It is a drive operator. It is a drive operator which perform in three steps. Which perform in three steps. Step number one. Step number one. First of all, cross product. Cross product. Yeah, you can say Cartesian product of R and S. Sir, what is the meaning of cross product या Cartesian product? Let us assume there are two relation R and S. There are two relation R and S. R1 having N1 tuple, S having N2 tuple. One having C1 attribute, this one having C2 attribute. So, whenever we do the cross product, my dear student, it is not a matrix multiplication. First of all, this point is crystal clear. Whenever we do the cross product, what happen? Tuple will be multiplied, N1 into N2 tuple and C1 plus C2 attribute. Yeah, columns. Whenever we do the cross product, first of all, tuple will be multiplied and column will be added. Second step, step second, select the tuple which satisfy utility condition on utility condition on all common attribute. All common attribute of R and S. All common attribute of R and S from R cross S. Step number one. Step third. My dear student, tell me one thing. Also note down this point na. You also note down, you're only listening. Write down in chat box what is happening. Step third. What is the step third? Projection of distinct attribute. Projection of distinct attribute, my dear. Projection of distinct attribute. Very good, Sham. These are the three steps. My dear. Now, can we start? Noted. It is important point only. Noted, beta. Noted. Now, here I am taking first of all question number 1. I am taking first of all question number 1 beta. So I erase the question number 2. I am taking first of all question number 1. Okay. Now listen bachcho. Here you can see there are one relation R ABC composed into R1. Please put your pen down and R2B, R1AB and R2B. Please put your pen down. I will explain first question. You will do the second question. Okay, bacha. I will take first question. You will do second question. Now here it is saying to decompose this table into subtable. Compose this table into subtable, my dear. Okay. AB and 1, 2, 3, 7, 7, 9. 7, 7, 9, 7, 9, 9, my. Okay. Now please listen. Here, what is happening, my dear student? What is happening? Here, R relation R1, AB is R2. Okay, bacha. Now here R1 having 3 tuple and 2 attribute, and R2 having 3 tuple and 2 attribute. So what is the role of R cross S? R1 into R2 is what? 3 into are getting 9 tuples. 2 plus 2, we are getting 4 attributes. 9 tuples and 4 attributes. Now, my dear student, what is the step first? It is not a matrix multiplication, first of all. It is not a matrix multiplication, so you will do in wrong manner, bacha. It is not a matrix multiplication, my dear. Keep this thing clear in your mind. It is not a matrix multiplication. How will write R1A, R1B, R2B and R2 is not a matrix or determinate. You do row and column wise. No. How you do? How you do, my dear student? How you do? You take all combination like this one, this one, this one, and for this one, this one, and for this tuple, this one, this one. For example, I'm taking. Don't worry. 1, 7. 1, 7 multiplied with 7, 7, 7, 9, 9, 9. What beta? 1, 7. Second one is 2, 7. 2, 7, my 7. 7 is multiplied by 7, 7, 7, 9, 9, 9. Clear, everyone? Next one is 3, 9. Bacho, I am teaching from the basic. Don't worry. Here I am explaining each and everything. 7, 9 and 9. This point is crystal clear, everyone. This point is crystal clear, everyone. What I told here, this is the step number 1. The step number 1. Let us assume you are a 3 student. You are a 3 student and 3 games. You are a 3 student and 3 games. So student number 1 participate in all 3 games. Student number 2 participate in all 3 games. And student number 3 participate in all three. Clear, bacha? For example, this 1 7 multiplied by 7 7 7 9 9. This is not a matrix, yeah, determinate. This is not a matrix multiplication, yeah, not a determinate. What is the simple sa concept? Here, this one tuple with multiplied with all possible combinations, like 7 7 7 9 9 9. 2 7, my dear. 7 7 7 9 9 9. 3 9, my dear. 7 7 7 9 and 9 9. This is the step number 1. Everyone, Jadip, crystal clear, beta? Somadeep, Jadip, Priya. So this is the step number 1 which we have done. This is the step number 1 which we have done, my dear. Cross product. Tuple will be multiplied and column will be added. Now, what is the second step? What is the second step? Select the tuples which satisfy equality condition. Which condition? Equality condition, my dear. Equality condition on all common attribute of R and S. All common attribute of R and S, my dear. So what is the common attribute here? What is the common attribute here? Here common attribute is B. You can see what is the common attribute here? Here common attribute is B. Here common attribute is B, my dear. B. Getting my point? So my dear student, here B is common. So what we do, the step number second, wherever, step second, I am writing here, step second, what we do, in step second, what is R1B is equal to R2B. We have to select that tuples where R1B equal to R2B. R1B equal to R2B. Clear, everyone? So here, where is the B value equal? Here, 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 and here. These 5 tuples in which B value are equal. These are the 5 tuples in which B value are equal, my. Which B value are equal, my. Clear, everyone? These are the 5 tuples in which B value are equal, my. Can everyone crystal clear? So what we do, we write these 5 R1A, R1B, R2, R2. What is the values? 1 7 7 7, 1 7 7 9, 7 7 7, 7 7 9, 3 9 9 9. Clear, everyone? This is the step 2. The step 2. Select the tuple which satisfy equality condition of common attribute. Equality condition of common attribute, my dear. Step number 3. Projection of distinct attribute. Projection of distinct attribute. What is the meaning of distinct attribute? If my name Vijay Agarwal appearing more than once, I will take one. I will take one. Like here, what is the distinct? A, B and C. Here B is appearing twice, but you will take only one. Now you have a question, sir, which one we will take first? R1 wala, R2 wala. So my dear, it is the equality condition. It is the equality condition. You can take any one, my dear. So here you can see A, B, A, B and C. A, B and C, my dear. A, B and C. Please listen carefully. What is the answer you are getting? 1 7 7, 1 7 9, 2 7 7, 2 7 9, 399. This is the output of R join S my. Or what is the original? 177,279,399. Are you getting my point? So here you can see, my dear student, you are getting these two yes tuple 179 and 277. These two are getting yes tuple, my dear. Yes tuple. Yeah, extra tuples. You are not getting exact same table which is given in the question. Are getting some yes, some extra tuples. So what we can conclude? What we can conclude? It is a lossy join compose. Each and every one, this point is crystal clear. Each and every one, this point is crystal clear. Kindly let me know, my dear, each and every student. Please let me know fast. Everyone. These are called yes tuple. Some extra tuples we are getting mean to say we are not getting the exact table whatever given in the. You're getting my point? But don't say, sir, you are getting whatever data table have na, you are getting some extra complementary. No, my dear, this is a different meaning. If you are getting exact table, then you can say it is a lossless. Clear, bacha? Everyone, crystal clear? Now, this is the question number 1 which I have done. Now, you will solve question number 2 right now. You will solve question number 2 right now, my dear. Decompose this table into AB and AC. AB and AC. Each and everyone participate, please. AB and AC. Everyone. Please, please, please. 17, 7. Each and everyone kindly solve. Every student participate. So here again R1 that is R2 that is, and what is happening, my dear? What is happening? It having a 3 tuple. It also having 3 tuples. 2 attribute, yeah, 2 column. Here also 2 attribute, yeah, 2 column. What we do when we do the cross product, n1 in n2 tuples, directly we can write 9 tuples plus 2, 4 attribute. Now, yes, everyone, you do fast. R1, R1, R2. The step R1 cross product. What we do, my dear? 1 7 multiplied with 7, 9 and 3. 7 multiplied with 179. Next 39 multiplied with 179 and 3. Clear, bacha? So what is the step second? What is the step second? Step second is what? Select the tuple which satisfy equality condition of common attribute. What is the common attribute here? A is common. What is the common attribute here? A is common, my dear student. A is, you can see R1A and R2. A is common, my dear. A is common. Where is the common attribute is satisfying? You can see, bacha. You can see here one and one and this. In these three tuples, you are getting. Then what is the step 2 result? What is the step 2 result? Step 2 result is R1A, R1B, R2A, R2. 1717, 729, 393. This is the step second. This is the step second, my dear. Still clear? Now step third. Step third. What? Projection of distinct attribute. Projection of distinct attribute. So my dear student, you can see here. Bacha. Here, what is the distinct? A is distinct na. What you are getting? 177, 279 and 399. You are getting exact table, whatever is given, 177, 279, 399. So what you can declare? R1 natural join R2. What you can declare, my dear student? You can declare it is a lossless join. Each and every one crystal clear. So I can directly explain the lossless with the help of binary method. But I want to explain first of all what is the meaning of lossy and what is the meaning of loss. That's why first of all I explain with the help of data. Now you let me know, bacho, this point is crystal clear. Here when you decompose into AB and BC, that time you are getting lossy. In question number 2, you are getting lossless join, But my dear student, this tabular method will not work. Listen carefully. Sir, why you explain for this method? You are wasting your time. No, my dear. I am giving the feeling of lossy and lossless because most of the student just read the question and learn the and memorize कि proper subset either a super key or a है ना, or R1 या super key of R2, then it will be lossless. But they don't know what is the meaning of lossy and what is the meaning of lossless, my dear. They don't know what is the meaning of lossy and what is the meaning of lossless. Now you getting कि if we are getting some spurious tuple, if we are getting some spurious means extra tuple, then we can say it's a lossy, because most of the students read the DBMS, they don't know what is the meaning of spurious technical term. That is nothing, it's a extra tuple. And if we are getting the exact table, then it is called lossless join. So, but my dear, we will not use by this table method. What we use, we have a two method for checking the lossless join. Okay, one is called binary method, yeah, FD approach. I'm saying FD approach. A binary method, you can say successive. Successive is also called. And another one is chase test. Chase test. Chase test. That is matrix method. Matrix approach. Matrix approach. Case test and binary method. Okay. Now, case test is also given in of Ullman, है ना? Especially case test is mentioned in Ullman, but you can do any approach. I prefer most of the time this FD approach, binary method, but we can do chase method also. If we are getting A, alpha, whatever, है ना? We can do chase test also. I will tell you both of the method. Don't worry, but I prefer binary method. Okay, FD approach, because chase test you make a table. I will tell you both, don't worry about that. Okay bacha. So first of all, I am telling lossless join decomposition method first. Lossless. Now listen carefully. Let R be the relational schema with FD set F is decomposed into subrelations R1 and R2. R1 and R2, my dear. Okay, R1 and R2. R1 join R2 lossless if and only if step number 1, when you do the union, are getting all attributes are. Second, if common attribute, if common attribute of R1 and R2 either a super key of R1 or of what I am telling, please try to understand. If whatever common attribute, you are taking a closure, you are taking a closure. If you are getting a super key of any of the relation, either you are getting a super key of R1 or you are getting a super key of R2, then it is called, lossless, my. Then it is called loss. This is the key concept. This is the key concept of loss. Or if common attribute, first of all you do the union, then you are getting exact R, then you can say. Second, if common attribute either a super key of R1 or a super key of R2, then you can say it is a any super key, any one relation, any one sub relation super key, then we can say it is a lossless. Now try to understand what is the meaning here. Lossless join decomposition. What beta? The book language. For the case R1 and R2, if we join, then we are getting exact relation R. If we join the instance, then we are getting exact relation R, then it is called lossless. Yeah, here you can see if R1 intersection R2 closure give R1, or if R1 intersection R2 closure give R2, then you can say lossless, sorry. Then you can say lossless, otherwise lossy. For example, please listen carefully. We have a one question RA and we have a FD and decompose R1 AB and R2 AC. Now you let me know Now you let me know, my dear, is it lossy or lossless? Is it lossy or lossless, my dear? Is it lossy or lossless? Because time is over, so I am telling here fastly. First of all, R1 and R2. What you are getting? Are getting A, B, C. Whatever relation attribute contain, that you are getting. Now, what is the common attribute? Common attribute is here, my dear. Common attribute is A. Common attribute is A, my dear. Common attribute is A. Still clear, bacha? When you take the closure of A, then what happen? Are getting AB, mean to say super key of R1. Super key of R1, my dear. What we can say? We can declare it a join. Can declare it is a lossless join, my dear. We can declare it is a lossless join. Now, in this context, second question, if for the same RAPC are getting R1AP and R2, now you let me know it is a lossy or lossless, my. Is a lossy or lossless. How we solve, my dear? First of all, R1 and R2. What we are getting? RA. Yes, sir. When we take the intersection, what is the common attribute? When you take the closure of B, are getting you are getting only B, my dear. Mean to say, not a super key of R1 and not super key of R2. You can say, my dear, you can say it is lossy. Is lossy. Very good, Seema. Now, please open your eyes. Open your eyes. Open your eyes. This is the question number 1. This is the question number 1. Or you can see here A tends to B, FD is satisfied. For this instance, A tends to be satisfying. So, when common attribute is B, you are getting lossy join. We discuss directly. But in question number 2, when common attribute is A and A tends to be FD, then what we are getting by tabular approach? Lossless join. And here directly you can say. Here directly you can say. Chamka, everyone. Chamka. So please read this concept. I am giving some question. You will solve. Okay. I'm giving as a homework. We will discuss this question. Another approach also we will discuss. The question number 1. Question number 1. Question number 2. This gate question or gate question also. Please. These 3 question I am giving as a homework. Now you let me know any doubt. So please ask, is there is any doubt? Everything is crystal clear, then kindly write down heart in the chat box. Everyone, please. There is any doubt? I have another class also, so I have to import the people. And so many things are there. Start that class on time. So I will not extend this class. That is the reason. But I will cover each and every topic. That is my promise. Okay. Don't worry. I have given this question as a homework. You will do tomorrow. Everyone crystal clear? So my dear student, Thank you, everyone. Thank you. Thank you. God bless everyone.